So in example 1b, we're also again asked to identify if this is completely factored. So let's kind of go about it by looking at our two terms. They are this one and this one. And if we look at their coefficients, 32 and 8, the largest number that divides into both 32 and 8 is 8. Yes, they're both divisible by 2, they're both divisible by 4, but they're both divisible by 8, so 8 is the largest. Then notice they both have a p. The first term has a p squared, the second term has a p to the first. We can only pull out the smallest exponent. So p is a part of our greatest common factor. And then notice they both have a q, and therefore q is going to be a part of our greatest common factor, and once again we can only pull out the smallest exponent, which is a 1, so our greatest common factor is 8pq. Well, good, that's what we see they have there. Now we want to check also to see if when we divide each term by 8pq, do we in fact get what's in the parentheses there. So when we're factoring, we're basically, now that we've got the greatest common factor, we're basically then taking each term in our polynomial and dividing by that 8pq. And remember that pq has an exponent of 1. Each of them does. So then we're also going to divide the second term, 8pq, by 8pq, our greatest common factor. And remember, these have an exponent of 1. So if we start with the first one, 32 divided by 8, that's 4. We know that when we divide like terms, we subtract their exponents. So when we divide p to the 2 by p to the 1, we get p to the 2 minus 1, which would be p to the 1. And when we divide q to the 4 by q to the 1, we get q to the 4 minus 1, which would be q to the 3. That's what we see here. So that's good so far. Now the second term. If we divide 8 by 8, we get 1. If we divide p by p, we get 1. If we divide q by q, we get 1. So when we divide the second term, 8pq, by our greatest common factor, we get 1. That's what we see here. So this one is completely factored.